All right. Hi. We are, we gotta keep moving. We have to keep moving. It is time for Unit 6. Oh my goodness, happy Friday. Whenever you're watching this, Saturday, Sunday night, third period before AP Chem. Hopefully it's not that. Crazy, we're on Unit 6 already. That means we only have 2 left to review because we're right on Unit 9. Let's roll. Unit 6 is thermochem, pretty easy unit. So, special type of equation that includes the heat involved is an thermochemical equation. In a blank reaction, the heat would be written as a reactant. That would be endothermic because you would need to use it. Heat would be going in. You're in a chemistry class and your teacher asks you to hold a beaker of water. She drops a cube of sodium hydroxide in the water. To your surprise and utter fascination, you feel the beaker warm up. Write the balanced equation of this reaction, including where heat should be appropriate. So I would take my sodium hydroxide cube plus H2O. That's going to give me sodium ions plus OH ions, because the sodium is going to rip the H off of the water. There's not going to be any water left because that's a strong base. Plus heat, because that is giving off heat. It is a product. Describe the difference between the system and surroundings of a system. How can we basically do this quickly? The system is the reaction. So that's reactants, products, all the molecules. Surroundings is everything else. So that could be the beaker, your hand. And usually the system does work on the surroundings. The above reaction is endothermic or exothermic. It's exothermic because the system has lost energy. The surroundings have gained energy. If the addition of heat is required to make a reaction happen, the reaction is endothermic. Breaking bonds, this is super important, is an endothermic process. Forming bonds is an exothermic process. Because if you think about that graph, it dips down when the bond is formed. It releases energy because it's going to a more stable process. So it takes heat to break the bonds, and it releases heat to make the bonds. Make sure you understand the difference between those two. Consider the following reaction. AB plus C yields AC plus B. The strength of the AB bond is 3 times greater than the strength of the AC bond. So AB is 3 times greater than AC. That would mean this reaction is endothermic, because it takes more energy to break that than to make that. Data shows only 12 to 30% of the energy from the fuel put into gasoline is converted into the actual work of moving down the road. What do you suppose happens to the remaining 88 to 70% of the energy? Where did it go? It goes to heat, which is lost to the surroundings. So we are essentially driving around heaters instead of, our combustion engines are just big old heaters. A lot of energy lost. Eventually we're going to make them more efficient. Hybrid cars are making a huge comeback right now. Battery-powered cars are actually kind of on the downswing. They're still out there. But more car makers are making battery-powered cars than... they're making more hybrid than battery cars right now. It's kind of interesting. Study the energy diagram for DE plus F yields DF plus E, using the information in the diagram to answer the following questions. So here's DE plus F. Here's DF plus E. What is the approximate potential energy of the reactants? 30. Usually this is going to be in kilojoules. Products, 10. What's the overall change in energy of this reaction? Negative 20 kilojoules. So the reaction is exothermic because the system is losing energy. During photosynthesis, light energy from the sun is used to convert carbon dioxide and water into oxygen and the high energy molecule glucose, sugar. Sketch an energy diagram in the box to the right showing this process. Include products reactants on the diagram. So, light from the sun is needed to convert it. So here is my reactants, here is my sunlight, here is my products. So here's my CO2 plus H2O. Here's my sunlight catalyst, I'd have to put in there. And then here is my O2 plus C6H12O6. So this is my activation energy I have to overcome with sunlight. Is the change in energy positive or negative? It's positive. Therefore, this is endothermic. It requires energy to be put in. Complete the table for each of the following physical changes. Water vaporizes, energy lost or gained. Gained. Water freezes, lost. Water condenses, lost. Endo or exo, in, out, out. Okay, flip the page. 6.3. You're making hard-boiled eggs to bring to school for lunch tomorrow. Ew. Consider the heat transfer for each step along the way. Complete the chart. I don't like hard-boiled eggs. I'll eat the whites, but the yellow parts, I'm out. What part of the system is gaining or losing heat at each step? The burner is going to go to the, does it give us the steps? Oh, here we go. A pan of water is placed onto the red burner of your stove. So heat is going to be gained by the pan. Eggs are placed in the water. So then the water is going to potentially lose, I'm going to read the whole thing. Eggs are placed in the water and the heat is turned off. Be sure to make enough to share with your friends. But not me, because I am your friend. Well, that's complicated. I'm your teacher. But I would be a friend that I wouldn't want the hard-boiled egg. Okay, let's keep going. You allow your eggs to sit in the water until you're ready to pack them in your lunchbox the next morning. How would you do that? I don't even know if that's, like, safe. Heat can be lost from the water. Go to the thermometer. Heat can be lost from the water. Go to the eggs. This is kind of basic. Heat can be lost from the eggs and go to the air once you take them out / surroundings. That was kind of a dumb chart. But now you know I don't want you to share eggs with me. When heat is applied to the solution, the particles increase in kinetic energy. As this change occurs, particles exchange or transfer energy with the solution in direction of hot to cold. Heat only flows from hot to cold until all particles reach the same temperature and achieve, you know what it is, equilibrium. Box A and B contain the same gas molecule. Which box is at a higher temperature? Well, we have to look at the average speed of all the arrows. And definitely box B, because the average of the arrows are longer. Molecules in which box have more energy? How do you know? B, because temperature equals average kinetic energy. Explain what would happen if the molecules of box A and B were mixed together. Use the words collide and energy in your explanation. Well, they would collide, particles would, until thermal equilibrium is reached, till they were all the same temperature. When two objects have reached thermal equilibrium, all of their molecules have the same average kinetic energy, and their temperature are the same. Remember, all the molecules do not move at the exact same temperature, ever. That would be wild. The same average kinetic energy. Okay, let's keep moving. Flip that page. You have two blocks of substance. Substance A, one that's 10 grams and one that's 100 grams. The specific heat of the 10-gram block is higher, lower, or the same as the 100-gram block? Same. It's the same material, so the same specific heat. 1,000 joules of heat are applied to both blocks. Which block will experience a greater temperature change? Prove it with the formula for heat. Well, it's going to be the 10-gram block because it's smaller. So if I did like MCAT, Q equals or SMAT, so that means that delta T would equal Q over MS. So you can see that the larger the mass, the larger the denominator is going to get, the smaller the change in temperature. Consider two substances, C and D. Substance C has a specific heat of 3.4 and D has a specific heat of 1.5. You apply the same amount of heat to 1 gram of each substance, which will experience a greater temperature change. Justify your claim using the formula for heat. Well, D will be greater because it has a lower specific heat. So if I'm solving for specific heat, we're solving for a greater temperature change. Once again, triangle T equals Q over MS. So the smaller the specific heat, the larger the whole change in temperature is going to be. So smaller specific heat is going to change the most. How is the change in temperature calculated? Triangle T equals TF minus TI. How is it possible for the quantity of heat to be negative? Well, heat absorbed is going to equal positive. Heat released is going to equal negative. What are generally accepted units for specific heat? Usually joules per grams degrees Celsius. And then sometimes they'll have you do like the heat of solution. It's all the same thing. If it's heat of solution, they're going to give you a solution. They will give you the heat of solution most of the times. In the chemistry lab today, you perform the reaction A, B yields C. The initial temperature of A and B was 30 degrees Celsius, while the final temperature of C was 15, a loss of energy. Does this disprove the first law of thermodynamics? Where did energy go? What happened? No, it does not, because matter's always conserved. So is energy. Energy was transferred to the surroundings. The system did not hold all of the energy. It went somewhere else. The beaker, the table, the lab, the air. It did not disappear. In the chemistry lab, you perform the reaction D plus F yields G. The initial temperature of D and F was 20, while the final temperature of C was 50. This should say G. A gain of energy. Does this disprove the first law of thermodynamics? No. Energy was so G was transferred into the system. So energy cannot be created or destroyed. It can only change forms. Oh man, we got a lot of math. How many pages do we have left? 1, 2, 3, 4, 5, 6. I'm going to pause here. Why don't you guys work through this page on your own, and then part 2 we'll start with this page so you can make sure that you can do your calorimetry calculations. So this will be on part 2. Thank you for watching Unit 6 Review with Mr. Heller. Goodbye.